everybody. I think we're going to get started. I'll let a tiny amount of settling go on. All right, my name is Daniel Gicklhorn. I'm a product manager from Azure's networking team. Today I'm going to talk about enterprise-grade content delivery with Microsoft Azure. Enterprise-grade is a term that's thrown around a lot, or at least enterprise scale is. Most people tend to talk about enterprise scale being super high reliability or super low performance or super high performance or elements of the actual metrics related to delivery, but little talk about what is the actual context around delivering enterprise grade applications. One of the things that I've noticed quite a bit is that there's very little sort of ethos around sort of private or custom CDN in a lot of these talks in the community, things like that. It's one of those things that's somewhat hidden because there's sort of the sort of dirty side of private CDN delivery, but then sort of there's the elements of enterprise scale that are starting to creep into public delivery across all sorts of different platforms. One of the big changes today, as many other presenters have talked about, is that enterprise applications are starting to need more and more real-time data. CDN starting to become more about streaming both directions instead of just a read and write type of application service. There's really a lot in VR, IoT, and platforms like that are starting to enter the common platform around CDN. And there's a lot that's changing about the broader ecosystem today. One of the things that's really changed a lot that sort of started to bridge the gap between what's considered traditionally consumer and enterprise scenarios is with GDPR and a lot of other standards coming out. There's basically a new sort of model where everyone has to be a data residency expert. Every service has to think about these things from the ground up. They can't just take a dependency on something because they're basically forced to think about their users, their data, regardless of the type of service. And so that's introducing basically a set of these really traditional enterprise scenarios into the common core of consumer applications, as well as enterprise applications are starting to come out of the dark and starting to look at CDN as an actual modern platform as those platforms are forced to support these kind of capabilities. A couple of those specifically are security, data residency and compliance, hybridized applications, and then a sort of model around multi-tenant performance that when you're operating a large-scale enterprise business, you have to manage all of the downstream customers from your multi-tenant business. Microsoft Azure has been a platform that Microsoft itself sells, as well as a concept within Microsoft where most of our businesses have also taken a similar kind of cloud journey over time. One of the things that's built through that journey for most of these applications has been our own cloud CDN. It's something that we've worked on for the last 5 years, something that supports most of the major businesses in Microsoft, and really focused on those enterprise applications and what's different about building large-scale, yes, high availability and high performance, but also complex operating climates for those kind of applications. There's a few businesses here, but it's really something that's been adopted fairly broadly. And it's something that within the company is not something we force. It's something that we also have to sell and pull people onto. It's really about building trust in a platform. It's something that over the last 5 years we've seen about 115% year-over-year growth of people moving onto the platform or those businesses subsequently growing on the platform. So, all of this comes in concert with building a global scale network. And Microsoft has one of the largest networks in the world, A lot of this is done for private access, basically, to Azure and to our other cloud services. One of the benefits of building a CDN when you're also building a global network is that it gives you a lot of control and operational context around delivering a CDN platform that really works well with the place that you're serving the content from and really starts to work in concert with the applications in the data center. We've talked about our network in various different places, but it is one of the sort of the hallmarks of getting access to the cloud is to being able to on-ramp and to privately connect. So what makes enterprise-grade applications enterprise-grade? I'm going to talk through a couple of specific scenarios around how applications that are considered enterprise-grade need to be supported by a common platform. So one, developing a common security model around applications of all different types and different regulatory climates and different general requirements is a challenging space, but it really means we have to develop a common security baseline for everything. Two, data residency and even service residency is a challenge, and it's not something that you can go pull an off-the-shelf appliance or anything to deal with. It has to be something that's intrinsic to the entire platform, especially when you're thinking CDN and you're cracking the payload when you're transmitting across the network. Building apps with a hybrid edge, there's been a lot of discussion today about what is the next version of edge versus CDN. That is something that's inherent when you're building large-scale applications, is that you have the benefit that they're building applications that have quite a broad footprint and a quite broad diversity of different application types, including ones that can run with some amount of power on the client machine. And then delivering performance as a service, not just a sales tactic, but really trying to integrate performance down through the full support stack, the full operational stack down to the individual application that they're running. So common security. Most folks are somewhat aware of the general regulatory climate in most places, but every country has different standards. Every application reacts to, say, tax standards differently in different locations, as well as these things change on basically a weekly basis these days. There's a long laundry list of regulatory requirements in different geographies, as well as a long set of regulatory requirements that most applications make up on themselves, either from their CISOs or from various other people within their organization. They create basically a regulatory environment that may or may not be just purely a environmental one. And then over time, as people have built their own services or these sorts of large applications, they've built their own service and incident automation that needs to be supported. So what does that really mean to deliver a security baseline at the edge? The key thing operating at the edge is that you can't really trust physical security. As much as we work with service operators, colo providers, things like that, there isn't really a good standard implemented globally across all of these things. And the deeper the edge goes, the less and less you have common context around security in those locations. And so it's really about replacing that physical security with something else. It's with logical controls and really understanding how data flows across the network. Couple of best practices in particular. One, meet your regulatory standards, but that can't be the limiting factor. Everything needs to be encrypted all of the time. And really, you need to treat the service data, the operation of the service, just as you would treat customer data, no matter when you're moving the data around. That's configuration. That's how you think about service logs. That's really thinking about the operational context holistically about, well, if all of these things might or may not have customer data in them, how do you handle that in the same way? Treating customer data as secrets is a hallmark of most regulatory requirements, is that it doesn't matter whether it just happens to be an email address and no password. It's still a secret and you can't predict what a customer is going to put in a HTTP request, in the header, in the individual request query string. High security data can be anywhere, and so we have to treat everything as a secret. The key thing there is to basically have really granular control over the path and scope of data. Where you put it should be where the application is. The last is really looking at security performance. Security is really viewed as an encumbrance to most applications, is that it's it may be part of their sort of general operating climate, but the more and more you can remove that from the overhead of their service, the less and less they have to think about it, the more and more they can take a dependency. And in general, the key thing that we found is automating security interrupt handling. So security incidents, security requirements, changing requirements and things like that don't generally come with a interrupt quality. And so one of the things that we definitely see with internal customers looking at our service as a service provider is that their asks to most public CDNs are, hey, I have some new requirement, how do you deal with it? Internally, we just assume that basically that's a stream that comes in, and we have an automated way for managing new requirements across a broad set of individual customer needs and things like that. So data and service residency at the edge. So there's a lot of new requirements as more applications that aren't traditional CDN applications start looking at CDN that to pose a challenge to the general concept of, cache rewrites, origin routing, and things like that. One is sort of more traditional traffic fencing. There are a lot of regional requirements for being able to hold traffic in a given region. Data fencing, which is more about how do you where do you store the data, how do you actually limit the scope of traffic traversing, a public network as well as a private network, and where does it land on the CDN, as well as where do you put not just the customer information, but where do you put your service logs and things like that. Private networks, think about government networks and other platforms like that. Do traditionally use CDN, but they often grant security exceptions to be able to deliver content from those networks to their end users because they're in a sealed environment. There is a huge number of services that have those kind of perforations in their security policy just to use traditional CDNs, and most large applications tend to have some level of interaction with a network or a customer that is looking at that kind of a network ceiling over time. And the last is per user data locality. One of the largest challenges with CDN networks is it assumes data is ubiquitous, replicated everywhere. But in general, with most large applications, not just enterprise, but the larger you get in consumer applications, the same level of challenge comes into play, which is you can't replicate data everywhere for everybody. Either it's due to regulatory requirements, due to just size and scale requirements, but it requires a level of logic handling where does data flow and how do you actually route a user to the data behind it without having to expose a fairly gross query string or do that kind of client-side routing that really doesn't provide a good user experience. There isn't really a silver bullet for solving all of these problems. There's basically a set of principles we've come up with. One is understand the application and really what does it need. Fail fast when an application comes in and says they need something different. Start to, basically work with the broader context to be able to be agile about how do you handle data flow and your control plane management. Trust the origin. There is no scalable solution for trying to manage a customer's data or a customer's data at a top level with a CDN. This has been tried in DNS services for a long time, or it ends up falling to the customer itself. Since there is that environment already, providing basically a better command and control interface to the customer for the CDN, for how do you do routing, for how do you do interrupt-based routing. Helps with that, and it allows you to solve sort of a lot of the data residency requirements by basically importing per-user rules back to the CDN. Match the handling policy to the service. Services operate in a lot of very unique locations. A lot of people have on-prem data centers that they serve origin from. Handling and managing that service as if they were managing it themselves is fairly critical to get to large-scale applications, or in particular, large-scale hybrid applications, ones that are running both in a consumer and enterprise scope, or with business customers as well as consumers. And the last is connect where the users do. There are a lot of connectivity strategies for connecting to private networks, but the reality is that anything that doesn't involve a sealed network is going to be a security exception, and it doesn't really land from a long-term perspective. Most of the folks we see, every time we take one of those exceptions, next year they're trying to get off, or the year after they're trying to get off, and the year after they're trying to get off, and trying to close those holes because they keep emerging over time. So the hybrid edge, there's a lot of conversations today about operating a hybrid edge environment. One of the benefits of what we call, what we consider enterprise-grade applications is that they're really focused on operating locally, and they tend to have rich end-user experiences. They're either developed on, sort of a Windows or Mac-based platform, or they're deployed as a, sort of high-overhead web app to be able to do the kind of auth and things that they need. When that happens, the CDN's role has an opportunity to expand, not just to deliver content from the front end, but to actually operate code on those platforms, either within the browser, within the client application, or anywhere in between. And as there's been some conversations about 5G and other sort of edge platforms. As customers are looking at a long-term cloud strategy, they're really starting to fragment their workloads across many different spaces, either from a combination of public cloud and on-prem, or places in between. So. There are quite a few different strategies we've taken to be able to move work that would traditionally be done sort of on an ad hoc basis to the client. One of those is a large-scale monitoring system in which we can embed in any client application a performance stack, basically, that will start to land telemetry back on the CDN to really look at an end-to-end solution so that you can maintain quality of experience, as well as a combination of different application routing types that can be spread across the whole platform. In particular, the benefit of moving closer and closer to the user is the closer you are to the user, the more likely you are operating within the context and the security and the guidelines and the guidance from that individual application. Because the closer you get to the user, the more likely you are in their network, on their platform, working with their data and things like that. The last is around end-user performance. And one of the real challenges, and this is, I hear very consistently that enterprises don't need performance, they just need reliability. And that's very not true. They're just willing to settle for it. So the reality is that most enterprise applications have the same level of challenges, have the same amount of complaints, and really have to operate competitively with performance amongst sort of the broader set of their goals. And one of the big challenges presented there is around subtenancy or performance. If say, we're providing a CDN service to Office and their users. They're providing Office as a service and a separate SLA down to their end users through their support channels and through their product offering. And the challenge ends up being with CDNs being a traditional black box service, they don't really get the kind of operational telemetry that's really isolated to the user experience of one of their customers. They generally get more of a broad global picture, a regional picture. And that does not scale when those individual applications are trying to provide a service or at least a debug experience down through to their individual customers. So one of the changes that we've made in terms of a broader investment has been looking at how do we do global scalable monitoring. Some of that, as I mentioned, is basically in concert with the client. The rest is really looking at how do you monitor true normal when you're looking at an individual user experience. And so today, if you're using Office, that device is monitoring its entire lifetime of communication down to Microsoft servers to be able to actually track a consistent user performance over time. And so if you call into support and say, hey, I'm having trouble connecting to Office, you basically get that support technician can actually look at the lifetime of your use and say, yes, you did have a problem on this day, and here's the root cause. And looking at the broader context of user experience requirements, you have to be able to provide that down to enterprise applications because they themselves are audited or do audit their individual applications. And so it really turns performance into more of a continuum of tracking, collecting, investigating, tuning, and reporting on the individual experience of a given user. In particular, some top-level items are thinking about it as an individual user experience is key because in many cases, if you're looking at a large enterprise network or an enterprise application that has enterprise customers, many of those users are clustered in, say, a gigantic network, like a gigantic corporate network, and don't have, they may all appear as a single IP address to the CDN. The other side is use RUM because we've basically found nothing that competes with having enough RUM data to be able to actually describe that user experience. The customer themselves need to be able to operate that data if they're going to provide a support experience. The customers themselves will then, once you've given them that data, give you a lot of feedback on where you can improve, and so that's something to be ready for. And then reporting and tracking, being able to provide that full history of data over time is key. A couple of top-level items. Don't trust physical security. It doesn't work. There is no way to get that. The deeper you get and the deeper you get into a provider's network, the less and less they're willing to give those guarantees at the margins that they're operating with. Don't fight resident data. Be able to handle it efficiently and be able to react to a customer coming in with a requirement that says, I've got 1 million users and each person's data is in a unique location. Develop across edges to establish trust and really to inherit compliance. The more and more you get close, the more and more you actually get that as a freebie. And the last is basically to treat performance as a continuum and really start to treat your CDN monitoring as part of the application monitoring. And last, as of today, at the beginning of this presentation, you can actually use our global network through Azure CDN. You check the Microsoft option. That will give you basically access to the same network that our first parties use, that our Microsoft applications use. It's built for a lot of these enterprise scenarios. The benefit is you basically get on our private network at the CDN layer from the start of the request. And you can expect a lot more from us over the next year. So, cool. Well, thanks. Any questions? All right, cool. Well, thank you.